Hello everyone. Hope you having a great time at the Northeast Scala Symposium 2023 so far. My name is Renaldi, and today I'm going to be going to my session implementing real-time sentiment analysis tools with Scala and GPT-4. So without further ado, let's get straight into it. So before we begin, let me tell you a bit about myself first. So I'm currently working as a software engineer for Seek Limited. I'm currently based in Melbourne, Australia, and I have quite a bit of cloud expertise, with me holding 13 certifications from AWS, and I currently am also a subject matter expert for the AWS Solutions Architect professional exam, as well as the AWS Data Analytics Specialist certification. I also am an international speaker. I've already spoken at more than 30 events on various topics, including programming-related topics for various languages, including Python, TypeScript, and many more, cloud-based topics, and project management topics as well. And I enjoy all things AWS, open source, and virtual reality as well. And if you'd like to connect with me to ask some questions or in general just have a chat, feel free to connect with me on my socials below as well. So for the agenda today, we'll be going into 5 different items. Firstly, I'm going to be introducing you to sentiment analysis and also why we are doing it. We're going to then go into looking at the technology stack, where this is currently located at, and how we're essentially going to build the particular architecture for our solution. After that, we're going to be looking at building the pipeline, which is essentially going to be building a sentimental analysis pipeline. And I'm going to be talking quite in depth about that. Afterwards, we then will go into testing and evaluating how our performance is going within the pipeline. And finally, we will then conclude with a demo. So, what is sentiment analysis? Let's go into this first. Well, it's really just more or less an automated process to be able to determine sentiment within text. It is a very popular field within machine learning and AI. There has been many models that are made to do this. Some of them have included naive Bayes, SVM, deep learning, such as RNN or LSTM. So a lot of models have been pretty much made to be able to do this. And it's been common for a lot of use cases. Some of them have been, for example, in analyzing customer reviews from their text, like, do they seem that they like the service they got from you or from someone else? And also, how are people responding as well on social media? It's been quite popular recently, especially in regarding to a lot of different topics, such as, for example, elections. People have been using the sentiment analysis to actually gauge how people are feeling towards, for example, say a particular candidate. So it's quite a big thing. And of course, there's much more use cases as well, aside from that too. And there have also been lexicon-based approaches as well, aside from the machine learning approaches that are mentioned too, which are basically using predefined sentiment word lists. So what is the motivation for using a real-time sentiment analysis tool, if at all? In general, we want better understanding of our community. So in many different communities, there are often different kinds of sentiments that can be put towards you. And as someone who creates content, oftentimes, you want to be someone who is able to understand how the community feels towards a particular content, or to be able to gauge how the community feels towards a particular event per se. So having a tool such as this is a very, very big thing, essentially, for you to be able to better understand that and better tailor your feedback to the community that way. Because what you need to understand is you want to be able to return the feedback accordingly to the community based on how they're feeling, and, well, in general, get them to also understand more about what you're trying to get through to them, essentially. So that's why it's very important to tailor a message importantly and understand the climate of how the community is currently feeling. Aside from that, of course, we want to be able to leverage the capabilities of GPT to be able to customize our responses and insights. And GPT is certainly going to play a big part of this tool because, as you know, GPT has been a big part of many discussions recently, and it's been subject to a lot of different use cases. And sentiment analysis is certainly one of the biggest things that's currently possibly being used for, because the biggest thing of this is that you particularly are able to communicate with it like you're communicating to a human. And that is essentially something that we have not been able to do easily so far yet. So that's why it's becoming a very popular thing within the field of sentiment analysis, because it's also able to more or less get a feel for what the sentiment is from people from communicating with them as well. It's very interesting because at one point I was just testing out ChatGPT as well, and testing out, like trying out different kind of like responses to see how to respond to different things. And one of the most interesting things I found about it that gave me this big aha moment was that I tried to actually put an irony, as in, yeah, particularly just a statement for just invoking some irony, and it was able to catch that, particularly that I was actually trying to put irony in a kind of like a sarcastic way. So that was very interesting, and I thought, all right, well, it clearly has the capability to be able to power this kind of tool. So, and it's also able to tailor based on that response too, which is a fantastic thing. But we're going to be looking at a slightly different approach than just purely sentimental analysis by ChatGPT, which we'll go into a bit later. So what is our technology stack looking like? Mostly it's comprised of 4 components, which are Discord, AWS's Comprehend, ChatGPT, and Scala. So in this particular case scenario, why are we using Discord? Well, Discord particularly is going to be our community thread per se, which is essentially where we're going to be getting our messages and how we're going to more or less be aggregating those messages and understanding the sentiment from those messages to then be put through back, essentially, in terms of how we can put through community the feedback necessary as part of this. And we're going to be using AWS Comprehend to be able to perform sentiment analysis. So we're going to connect to the API for AWS Comprehend to be able to then process the text that we receive accordingly, while we then also use ChatGPT to be able to take the sentiment analysis results that have been put through with personalized, while also taking the text that has been provided to it as well, and more or less tailoring a response particularly towards the user, which is definitely what we want. And finally, of course, Scala plays a big role in this because it's the orchestrator of this all. Everything is moving because of Scala, because we are particularly making things flow from start to finish in the pipeline because we have Scala coordinating everything essentially. So let's take a look at architecture. More or less, it's not a very complicated architecture in terms of, complicated architectures. So we first have information that is fed into Scala with Discord. So we feed in information real time from Discord into Scala, which is basically going to aggregate the information, put it into files essentially, which then it ingests, and it then particularly throws it into AWS Comprehend. But before that, it particularly uses the Lambda function. It basically does this through sending through API requests to the Lambda function. And the Lambda function essentially is going to deliver the necessary secret keys per se that the Scala functions needs essentially. So basically it fetches secrets from Secrets Manager in AWS. It fetches them, it sends them through, and basically it then sends things through to AWS Comprehend, because then it's basically, you need a few API keys for this. You need the ChatGPT API key and the AWS key. So these kind of things you normally don't want to store directly on local computer. So basically what we want to do, especially if you're working in a production environment, of course, you don't want that to be stored on your production environment. So basically what we do is, we store it in Secrets Manager and we fetch it through the Lambda through secure API calls. And aside from that, we then basically deliver the data directly to AWS Comprehend, and AWS Comprehend pretty much has this data, which we also then forward to ChatGPT. So there are two things that are forwarded to ChatGPT. Firstly, the result of the sentiment analysis that's performed by AWS Comprehend. And secondly, the main text that is put through to Scala, which is also then fed to ChatGPT, which then helps it appropriately create a response based on those two sentiments. So it helps tailor the response before then Scala is then able to aggregate the results, and you can either choose to tailor responses based on your feedback given by ChatGPT to you, or you can actually automate responses by ChatGPT to Discord, which is actually a big thing. Now, in this presentation, I'm not going to be going too deep into the inner workings of Discord, including, for example, like the API or how you can actually send messages back into it, because, well, that's a bit out of scope, and I want to focus more on the implementation of the sentiment analysis itself. So we're not going to be talking too deeply into that, but more or less going to be talking at quite a high level on that. So this is more or less how our architecture is going to look. So how is our initial setup going to look like? Well, firstly, we need to be able to set up for the dependencies that are required as part of this. So there are 6 main dependencies that are needed. Firstly, logging. We, of course, want to continuously log if there are any errors that occur and if there are any warnings that we catch as well. So these kinds of things, like, we want to essentially keep catching them, and so we respond to them accordingly. It also makes debugging much easier. Second is the Akka framework, which I'm sure some of you might have already familiar with if you're already used to the world of Scala. And aside from that, we also more or less will also use an HTTP client as well. We also will use JSON processing as a dependency, because we'll be dealing with some JSON objects as well. And you'll be seeing this as well, because when we deal with HTTP responses, for example, from, say, ChatGPT, we'll need to be able to understand how we can actually use JSON to be able to process that and accordingly return responses as needed. Other than that, we'll also be using the AWS SDK, and this is going to be used because we want to communicate with AWS or Amazon Comprehend. So Amazon Comprehend essentially, as mentioned before, is just a sentiment analysis tool. It can be made for so much more as well. You can tailor basically like the what parameters you want, how many different parameters you could actually want to perform sentiment analysis on, or if you actually want to, for example, have a commonality topic that you actually want to catch, for example, as in you're able to more or less like catch common words that are put through. So that's just some examples of what Amazon Comprehend can do. And aside from that, testing framework as well, because we want to be able to write stringent tests and be able to ensure that our Scala app is running as necessary. Aside from that, we also want to configure the AWS SDK appropriately too. So this includes more or less being able to just declare the secret key and the necessary API key as well to connect to AWS. So that's just one part of it. And aside from that, it's just setting up the Amazon Comprehend to be able to ingest the requests that are being put through appropriately, and more or less just be prepared for that. And aside from that, it's also about accessing GPT-4. GPT-4 is one of ChatGPT's models, one of the Open API foundational models. So basically, you're able to use this usually if particularly you feel that you want to be able to get a more accurate response, because as you're made me familiar, GPT has two pretty well-known models, GPT-3 and GPT 3.5 and GPT-4. And at the moment, GPT-4 is their most advanced text processing model, so text generation model, sorry. And you're actually able to get better and more accurate responses. So basically, we want to be able to set it up for that. So whether you use GPT 3.5 or 4 is completely up to you, but just take into account what is your use case and what is the degree of error that you can actually more or less give leeway to. I personally use GPT 3.5 for my API when I feel I just want to generate general text content, but if I actually want to generate more accurate text content, for example, say if I actually want to do more work on trying to recommend people things, for example, based on traveling experiences, like maybe 4 is better, but if I want to generate, for example, fiction, maybe 3.5 is better. So at the end of the day, it's really dependent as well on like your use case and how you feel you want to tailor your content appropriately as well. So we'll go into the code directly now. So we'll go into firstly the first part of building the sentiment analysis pipeline. So as you can see here, we firstly will more or less create a comprehend client helper. So what we want us to be able to do is have a connection to AWS and just in general create a new instance of the comprehend AWS service. So here you can see we're declaring our credentials. We're also declaring our credentials provider, which in turn creates the appropriate credentials object to be able to be ingested by AWS so we can connect to it. Then we declare a client so that we can then more or less create a comprehend client and build that appropriately, connect to the AP Southeast 1 region. So that region is basically the region that I'm currently in, which is basically Sydney. Well, not the one I'm currently in, but the closest region to me that I choose because of the latency. And in this case scenario, we're basically just building that based off of that. And aside from that, we're also creating a detect sentiment function as well. So as you can see, we're more or less creating a detect sentiment function which is able to take in the text that we then put in. And you'll see this in action later. So what we do here is that we more or less make a request. We actually then put a builder for the detect sentiment request, and we more or less just specify what the language code will be in English and just put the text in, and it will then appropriately give the response to us in the form of a sentiment score. Now the second part will be based on building the analyze sentiment function itself. So what we want to do here is more or less we want to analyze the sentiment that we actually put in, right? So in this particular case scenario, we're just going by a simpler rule for the purposes of this demonstration. We want to be able to determine if the sentiment score is above 0.5 for positive, then it's going to be classified as a positive. Otherwise, it will be classified as a negative. Now, how does the scoring work? Well, the scoring works in Amazon comprehend itself. So basically, we feed it there. It basically does the sentiment analysis within that, returns us to the score, and then we classify it based on that. And after that, we more or less just put the messages accordingly. So you might be familiar, if you're to use ChatGPT, that it has more or less a role-based system sometimes. So in this sort of case scenario, we're basically just putting in, the fact that we are the users, we have the text that we put in, and also the message as well, by the system, which is basically from the AWS side itself, and essentially from more or less what ChatGPT is going to return to us as well. We then put in a request body object, which more or less just is to be able to declare necessary parameters. So in this particular case scenario, we're saying that we want the GPT 3.5 turbo model, because as I mentioned before, in this case scenario, I don't mind too much about accuracy, and I just more or less want to see their insights. Now, you can feel free to play around with this as you want. Try GPT-4, GPT 3.5. You can even try playing around with the other foundational models that's been released as well, because a lot of them have very similar ways of usage. Like, for example, I've been playing around recently with Amazon Bedrock, with some of their tools, for example, with their AI 21 foundational models or their Amazon Titan model. So there's a lot that can be played around with. And there's not really a best foundational model as far as I know, because at the end of the day, everyone is going to be tailored towards, well, your own use case. Some might be more accurate towards some certain use cases, while others might be more accurate towards other ones. So it's always just a matter of experimenting and seeing which one best fits you. We then submit a request, and we make a basic request as part of this. So we put in a couple of headers. We put in the authorization header, which, as you might know, is usually necessary for these kinds of requests. We put the bearer, which is basically taking in the API key of ChatGPT in this particular case scenario, and we also put declaring a content type header as well, and we're declaring that as application JSON. We're posting the OpenAI API towards the OpenAI API endpoint as well, so that we're able to complete what we are currently doing. And we particularly just put in the request body too. So afterwards, we then send the request appropriately and get the response back. So in this case scenario, I'm just logging in the response because I actually want to see how it looks like. And we'll see that in a demo as well, just for your usage as well. And then we extract the sentiment appropriately and put it in the response. After that, moving on to the third part, we then create another function, which is basically to extract the sentiment. So in this particular case scenario, we want to be able to more or less create two different cases, right and left. One for error, and essentially like one for if we actually try to parse the body. So basically what we want to try to do here is we basically want to pick the best possible choice. Well, not really best possible choice. We picked essentially the best predicted choice from here, and we more or less just print the generated text and have the more or less just have the appropriate analyzing of the text being done here. And finally, this is where we feed the data. So in this case scenario, we're basically taking in data directly from our provider. So we're basically just taking in data that has been already aggregated for the purpose of this demo. So in this case scenario, we have declared we want to have a sentiment flow. So this basically is just taking in a flow, and it's basically just going from a function, it's mapping text to the ChatGPT client to be able to execute the analyzed sentiment text. And afterwards, we then declare a sync, which basically just prepares to do a print ln on each of them, and we basically have an analysis pipeline which we then feed the data that we currently have from our sentiment source to the community sync essentially, which is then able to help us do the completion work for this and appropriately feeds it to be able to be taken in from comprehend, which then is fed into ChatGPT, and pretty much is returned back to us as well in the form of a sentiment too. So as part of this, there's definitely going to be a lot of necessary testing and evaluation. Some of this testing and evaluation includes being able to refine prompts accordingly, and we're going to be talking about refining prompts in a bit as well. I prepared a special slide on that because I recognize how important it is within this kind of work and would like to do a bit of more guidance on how to do that too. Aside from that, there's also the necessity of accuracy and response time too. Sometimes it is very important to be able to pinpoint as well, like the accuracy of the responses as well, like are they appropriately doing things nicely as well. And that's why it's very important to look towards fine-tuning models. Now, fine-tuning models has been something that has not been really done by much of the open source community, but it's certainly a big thing that's more and more people are getting into, especially corporations, because people want models that actually can learn from their current knowledge base and are able to perform accordingly based on what they're asked to. So because of this, it's very important to verify the accuracy and validate how it is going. And aside from that too, the response time it can be based on a few factors. One of them is how you choose to word your prompt. And that's why prompt engineering is a big thing. And that's why we're going to be talking a bit about it later too. But we want to be able to reduce the response time as much as possible so, well, our users are satisfied as well. Aside from that, we also have comparing responses from different models too. So as I mentioned before, it's always a matter of experimentation. You just have to try out the different models, see how it responds to different prompts, and more or less just try to see which one fits you best. Because at the end of the day, every model has its own benefits and weaknesses. So all we can do is more or less just play around with models, get a good understanding for them, and just try them out, really. And the ultimate goal from all this really is to be able to just create for customizability. We want to be able to allow others to build on the deployment as well, which in turn sets more stages too. So if you see how I particularly built my pipeline for sentiment analysis, I try to do it in a staged way. And I feel like what we want to try to do is we want to add on to the stages eventually. So, for example, if we actually want to put it on a proper CI/CD pipeline, we want to be able to ensure that we know that, yeah, we're doing this particular build stage here. Then we want to be able to feed it here. Then we want to be able to put out the document. For example, if we do want to extract the stuff that we currently have into a document, we want to be able to have that capability easily. We want the extensibility, and that is why it is very important that we create for customizability. And this also in general helps us provide more features as well, as I mentioned, opportunities for adding features as well, as I was mentioning before. We want to be able to extend on it easily, and this can also help a lot for open source too, because as I'm mentioning before as well, a lot of open source work can really benefit a lot from what we do from preparing for extending these particular services. So we can essentially encourage the community better to contribute code better if we actually maintain good code contribution practices ourselves. So providing a space for community members to extend themselves is already a big step towards that. And it's certainly something that I have continuously put on the forefront of my mind while I work on this project. And within prompt engineering, getting into it now, there are three main stages essentially. First is within experimentation. So in general, it's just more or less just trying out different prompts, seeing how they go, seeing how the AI responds to you. Because the thing about generative AI, as you know, is that they always give a different response, but some have a more distinct pattern than others. And of course, it's all about your own use case. So you need to find out which one best works for you. After that, we then want to be able to optimize. So in optimization, we want to be able to continuously find out how we reduce the API call times. How do we want to be able to reduce the time that OpenAI communicates with my environment? Because at the end of the day, users want fast latency. They don't want long latency essentially. So we need to be able to provide them a better experience, and that's the whole point of optimization. And aside from that, relearning is a key point as well. And relearning is kind of a double-sided thing. So the first side really is in general just for your model to more or less be relearning from itself, because we want our model to continuously train itself as well. And that's one of the things I'm going to cover as well in the slide after this too. But the other side of it as well is how you also continuously learn from what you've seen as well is very important. So how do you apply what you've seen, your experiences? It's all very important to be able to create a proper functioning code for this particular implementation. And as I was mentioning before, here's basically just a slide to more or less talk a bit about refining prompts as well. So for example, in this case scenario, I'm basically just asking like provide an executive summary towards this particular Slack thread, and we're just more or less putting the Slack thread here. But instead, we could actually say something like we could actually divide it into two different sections, which is like question. We specifically specify where the question is so that ChatGPT isn't confused. So in this case scenario, we're just mentioning the question, provide an executive summary towards the Slack thread, and then we more or less just put the Slack thread there. So this helps ChatGPT to be able to process this information easier compared to actually if we put it at the same paragraph. Now, that's not to say that ChatGPT, for example, can't handle that, because it clearly can. I've already tried that and it was able to summarize stuff, for example, pretty well. But that being said, it sometimes can and sometimes can't. And that's the thing about generative AI. They don't always maintain their state and their responses in a continuous manner. Same goes as well for every other foundational model or LLM that you encounter as well. So it's always this matter of experimentation and finding out which prompts it really responds the best to. And another example particularly that I want to mention as well is particularly similar to like what I mentioned before, actually building on what I was mentioning before about relearning. So we want to be able to get the AI to learn from its own response, which is also a great approach too. So for example, I could actually create a prompt that says like, based on your previous response, create a better executive summary that is briefer. So in this case now, we're just more or less mentioning in that way that we want them to be able to summarize their summarized summary, essentially. So in this way, we're getting it to learn from itself and actually improving on the previous response. And this in general just is able to make things much, much better at some points, because it sees its previous response. And that is why as well, when I built this particular application, I made it retain memory too, because well, the best kind of like Gen AI is the ones that have conversational memory that it can refer on. And it is certainly a good thing to have when you consider these kinds of things, so that it can relearn from itself too. So now I'm going to be showing a bit of a demo that will more or less give you an idea of how this kind of project would be built and how it more or less would run. Now, keep in mind that there's a lot of debugging that is going to be pretty much seen in this screen. So expect it to be a bit messy, but I'm particularly including debugging this time around to get more or less a sense of the responses that, for example, ChatGPT returns as well, and the HTTP responses that will more or less be returned too, so that you too can more or less debug this on your own as well when you try these particular implementations too. So in this particular case scenario, we're running the SBT first, more or less to be able to build our project appropriately. We start an SBT server with that, and we run our sentiment analysis app. And after that, we can see that it successfully managed to complete. And as you can see, there's a ton of output. Now, this is always a bit hard to navigate, but pretty much the gist of it is that this is basically just a lot of HTTP requests. And however, what I really want to focus on here is just more or less just seeing the response that are returned from comprehend, more or less from AWS comprehend, for example, in this case scenario, how they're particularly responding to these, and also the ChatGPT response. Look at how it's able to generate the content. That's great to hear. What do you love about it? Because we fed it particularly with positive content, for example, in this case scenario, and the aggregated responses that we currently already put through to it. So this way we can actually see as well like the tokens that are put in and all that too. So similarly, for another response that may be negative, it is also able to then respond appropriately like, I am sorry to hear that. Like, can you please give me more context or specific details about what is bothering you? So appropriately, it's able to respond with that, and it generates the sentiment appropriately and responds appropriately based on that. And what we can do from this is that we can essentially then appropriately automate the response mechanism and send the response back to the user essentially. So this way we can either make our own tailored responses manually, or have, for example, ChatGPT send back the responses by what it makes itself. So we can see from this that it is a very powerful tool. And also notice, well, you see the decimal numbers at the bottom, for example, the minus 0.79666. It's 1 1. It's basically part of the analysis as part of the sentiment analysis too. So it's basically just giving a score for that too. So basically we're keeping track of things this way easily. And with that, we're creating a continuous mechanism that we're able to continually back and forth analyze responses and appropriately also automate it so that users are able to get tailored responses, and we also get great insights based on the sentiments that are put through by them as well. So seeing from that demo, I'm pretty sure that a lot of you have seen and kind of like grasped as well the potential as well that this has towards many use cases. So what challenges are we looking at? First is ethical considerations. There's definitely have been a lot of talk on how generative AI, for example, is going to be a threat towards copyright, towards art, towards, in general, we've seen a lot of things that has been talked about in regards to this. And of course, as well as the potential for it to have hallucinations. Hallucinations in this case just more or less means of how it sometimes generates fictional facts. Like, for example, it could create a new library in programming that you've never even heard about, for example, in Scala. Or it could actually, for example, invent a new city in the US, like when you actually just ask, like, what's the best city to go to? Like, granted, those are probably, you can't probably ask that anymore and just like expect it to actually give like a wrong answer anymore, because yeah, those are pretty simple cases, but there are a lot of cases that they actually give like wrong answers to, and that is subject to a lot of debate. And aside from that, there is not really a direct library as well to use ChatGPT and Scala too, because as you can see, I have to pretty much use HTTP call as well to particularly HTTP request as well to actually call the API endpoint of ChatGPT. And more or less, it's just in general just a bit harder, I'd say, to use compared to like some language that that they have made a lot of development on, and that there have been a lot of open source development on, for example, like say Python. So it's definitely, I feel like, quite some development to do within this space. And the other part of it is really security, because it's always been the consideration as well. Like people have been always asking, like, like are our data being trained, like our data that we feed in being trained by ChatGPT, or is there potential compromise for our stuff from ChatGPT? And for me, the question has probably always been answered by it's just more or less just a matter of like how you choose to use it, because the most catastrophic stuff that I've seen happen is when people nonchalantly feed in, like, for example, say their API keys into ChatGPT, which, well, that's not going to end well. So at the end of the day, it's just about having clear policies on how you use ChatGPT and LLMs, and more or less, as a Scala developer, you won't have any issues as long as you know its pitfalls and how you can actually avoid them. So, what are future work that can be done on this? Firstly, in terms of scalability, there can definitely be a lot of work in being able to scale the loads that are particularly put to this accordingly. Because as mentioned before, this is more or less just a very brief workload. It's quite a small workload. There isn't too much sentiments being put at the same time yet. But if, say, for example, we're putting it on kind of like a server that fast forwards you, let's say, about like 50K responses per minute, can you actually handle that properly? So it's always a matter of understanding how you're able to scale these loads and how you can actually better do that. And certainly something I want to look to as well as I continue scaling this project too. And aside from that, it's the deployment considerations too. You need to think about where you want to deploy this as well. And it's for me too, because right now the project is pretty much still a local project, but it's certainly, as it scales, it's going to be important to consider where it's going to be deployed. For example, if it's going to be containerized, I'm going to put it in a cloud. It's definitely an important thing. And aside from that, just really being able to put more room for extensibility to respond directly as well from the AI too is an important thing. And in general, for people to build on as well is a very important thing too. I've always pretty much tried to keep this project quite open for development in general in terms of extensibility, but I feel like that's why I want to encourage the community to also put more open source effort as well within these kinds of applications too. So what are the key takeaways? Well, firstly, we can see that Scala has a very big potential for being able to perform sentimental analysis with different tools such as ChatGPT and AWS's services. So as you can see here, we have a lot of potential to be able to control the flow of information, build a pipeline with Scala, and more or less generate smart insights from that too. We can actually generate better things and better insights that we can build on, that we can actually eventually maybe fine tune our AI onto as well, because it's becoming more of a thing too. And aside from that, we can continue the big trend of generative AI within Scala as well. And I feel like this is why, again, it's very important for the community to get involved more in this area too. And that's what I hope will be the future of Scala too, to be able to have more people delving into the area of generative AI and just doing their own experimentations and doing more sharing in the community, because that's, of course, how you build libraries, how you can continue like fostering further growth of Scala based on the Gen AI space, because certainly an area that has been developing very fast and is sure to continue developing fast as well towards the future. So that is all from me. Thank you so much for listening to my session. And again, if you have any questions, feel free to connect with me directly as well. As you can see from my socials, I have my Twitter, I have my LinkedIn, I have my GitHub. And I will now hand back to the organizers.